and I'm spinning up a GPU instance on Modal that's going to have a YOLO, you only look once object model, a little tiny one running on a GPU still, because then we can get like a few milliseconds of latency in response. And there we go. Okay, so now it's like identifying stuff live. If I move, it'll catch the chair. Yeah. And so because we're using the WebRTC stack, despite the fact that this cloud infrastructure not like running on my local machine, you get something pretty close to that local.
We have Charles from Modal joining us to talk about all things GPU. Charles is one of my favorite people to hang out with and talk about machine learning and other things with. I followed Charles for a while on the various platforms where you follow people, but then I actually got to know him a little bit during the Hamel and Dan course on fine tuning that I signed up for last year as a forcing function to spend more time fine tuning models. Then that course turned into this crazy, fun community experience, which is a big part of the inspiration for this course. I did a ton of Llama 3 fine tuning on Modal during that course, and I bothered Charles a lot in the course Discord for help, and he was really accommodating. It was a great learning experience for me, really fun, really interesting. Gave me a much, much better sense of what the tools you have to kind of leverage these models are and where the boundary is between prompt engineering, scaffolding, and fine tuning, which are all overlapping techniques for building reliable production voice AI things. And in a world where everything is moving fast, all three of those things are really valuable. And it's good to have a sense of kind of what they all do and how to reach for the various kind of strengths of each of those three tools. More recently, when we started work on the smart turn model, we just did all the training on Modal. We also can train that model locally, and I have a new 5090, which I'm excited to post about on social and try to make everybody extremely jealous in my world. But I still think we'll probably do most of the training on Modal because it's such a great platform for exactly that kind of thing. And one of the goals with the Smart Turn Model project is to make training and experimenting with that model very accessible. So if you have a script and you can just do a modal run train.py and you've got a training job going, that's such a great thing for all of us and a great thing, I think, for building a community around projects like that. Charles has done a bunch of really cool things, which he probably won't really talk about here, but a couple of them that you might want to dig up and we'll post in the Discord. A long time ago, Charles did a 1995 era Twitter simulation, which tickles me to this day. I'm old enough that I remember the celebrities from 1995, and it's shockingly spot on. There's a lot of Bill Clinton jokes in that demo or that experiment. And Charles wrote a bunch of stuff about how GPUs work, which is super valuable if you're coming from a CPU-oriented software background and getting up to speed with what GPUs really do and why we use them for these models. I will turn it over to Charles to talk about Modal and anything else he wants to talk about. Over to you, Charles. Thank you so much for joining us.
Yeah, thanks so much for having me, Quinn. It's been really great in the last couple weeks working and talking with Quinn about real-time communication on the web and how we can support it on Modal. And I'm excited for this course and to be able to contribute to it. And so my plan here was to do a little quick thing where I'd kind of like demoed Modal because I'm sure not everybody has seen it or tried it. And then I'll maybe do a few quick slides and then we'll open up the floor for questions and office hours. So what you should be seeing is on the left, my terminal, and on the right, the modal docs and examples. That web page on the right there, we have like firm belief that people learn by examples. So we have a wide variety of examples on everything from language models to protein folding, where you can go and check them out. And I spend a lot of my time maintaining, monitoring, and improving these examples so that they actually work. So it'd be a real shame if nobody ever ran them except my synthetic monitoring jobs. So just trying to guilt you into trying them out. But what are you going to get when you try out those examples? I want to show you that over in this terminal here. So this is what Modal looks like when you incorporate it into your Python application. Modal takes your Python code and runs it in the cloud. So as Quinn suggested, that's great for training because you write a little training script and you like play around with it locally. Maybe you play around with it on your sweet new 5090. But then when you want to run it on 10 GPUs because you want to run a hyperparameter sweep, or you want to deploy and turn it into a web service. Like cloud infrastructure is probably your best bet for solving that problem. And so Modal tries to make that as easy as possible. And so here's what that looks like, just a few lines of code. We've got a little SDK in Python for defining these things. You say, all right, there's an application that I want to create on Modal, and that is made up of a bunch of things. Maybe the most important one is a function that I want to run. So this is a square function that's going to run on Modal's remote infrastructure and just like square a number. So not a great use, I would say, of cloud infrastructure, but it's not so bad. So let's do Modal run get started. Okay, great. Square is a number. That's pretty cool. So just showing you a little bit of what happened there. This code was like sent over to Modal's cloud, like started running on a machine, and like I can change this to like something else. Square instead of is looks like it is. And then let's do that. And then I can run it again. Like that new code had to be shipped up there and then run, and the results returned back. And that happens like faster than I can describe it. So a lot of that is we did a lot of work on like speeding up the like container stack with some like custom pieces, like Docker compatible, but custom pieces. It's annoying that you can't say what the numbers you want to square is. So let's change that. Let's make it actually something you can pass in. So this down here is like code that I want to run locally to set up a thing that I want to do on Modal. So like this in your training script, maybe you'd collect up some configuration information and then send it along or something like that. So this is used a lot in this sort of like scriptier ways of using Modal, where you're doing something like training. So let's do Modal run get started.py. Now that takes an argument, x, that we're going to square, and let's do, yeah, 10. Cool. All right, now we're squaring the number 10. This may not seem that cool because we're not like actually using any fancy infrastructure. Let's say we wanted like an H100 to run this on, and maybe to show you that's happening, let me just do what everybody loves to do when they get a hold of a new GPU, which is run NVIDIA SMI, and just take a look what's going on that GPU. How hot is it? How many bytes do we got of memory on that thing? So let's run that. Let's now square a code, square a number without using the GPU. So again, total profligate use of cloud resources. So here we see NVIDIA SMI output indicating that this ran on a cloud GPU. You love to see it. That is all like using Modal to run like a kind of scripty kind of experience. So let me, for something that's maybe, so that's if you are fine tuning, you probably need to fine tune. If you're going for super low latency and you want higher intelligence these days, you need to fine tune for a specific task. A lot of the like speech to speech models are not super intelligent. And so you might need some fine tuning to be able to get your tasks into that number of weights. But Modal's not just for that. The other thing it can be used for is like deploying applications to the web. So we got a bunch of examples in here in our documentation of like how to deploy stuff to the web. And the one I've been working on recently with a little bit of advice from Quinn is some like Web RTC demos so that you can do real-time communication. And so this is, you'll see if you want to find the code for this, it's in a branch of our examples repo, which I could link in the chat later. This is relatively new to us. WebRTC used to just be for doing video calls like the one that we're on right now. But now that there's something other than a webcam or a microphone that can produce human-like real-time audio and video, all of a sudden it becomes useful to attach that WebRTC stack onto GPUs. So we've been working on that. And I think, let's see, let's just pull that guy up. And let me just do a quick demo. This is now a URL. I'm not going to share it with you because I'm actually just running like a quick development server. So in principle, you could copy that URL from over there and try the thing out. But in practice, it might not work super great because it's just this little development version. But yeah, so you should be seeing another copy of a webcam with me in it there. And I'm spinning up a GPU instance on Modal that's going to have a YOLO, you only look once object model, a little tiny one running on a GPU still, because then we can get like a few milliseconds of latency in response. And there we go. Okay, so now it's like identifying stuff live. If I move, it'll catch the chair. Yeah. And so because we're using the WebRTC stack, despite the fact that this cloud infrastructure not like running on my local machine, you get something pretty close to that local feel. Weird list of objects. Should probably have put stuff that's in my office, but you can get it to notice interesting stuff. So that runs like the GPU containers on Modal, and we do the negotiation of the WebRTC connection on Modal. So this one does it like entirely by hand by ourselves. But one of the main things we learned from that experience is that we should just use Pipecat probably. So that's probably the next step with that, to get it to use Pipecat, and probably daily too. But yeah, this is like a little web app running on Modal. The like front end is served from Modal. So it's a JavaScript front end. It's served by a fast API server to clients, and the WebRTC negotiation done with Modal. You can see some stuff about like web sockets for negotiation, all that stuff. So it's like pretty generic infrastructure. And that brings me to the like 2 or 3 slides that I want to run through, so there's not just me in my like terminal showing you stuff. So like the vision with Modal is to take like an old idea and make it fashion like remote procedure calling. There was this idea that, oh, wouldn't it be cool if you could call a function that was like on your mainframe? I know at least Quinn is experienced enough to have been traumatized by enterprise Java beans. And so it's the same idea. You have some code that you want to define, that you want to be able to run. Like it relies on infrastructure that's not present like a GPU. It relies on storage. It relies on networking, something that's not present in your local environment. And so that's like kind of the core of Modal, is like doing this for Python and making it actually good. And the fun thing about that is that that pretty naturally turns into deployment of applications, which end up like running on cloud infrastructure. Yeah, so the new things that make this RPC is an old idea, so why is this cool to do now? There's a lot of acceleration hardware, GPUs, that people want. Turns out once you start running stuff where like on one day you can trend on social media, be on Hacker News, and have a 10,000x increase in traffic, all of a sudden you need like rapid automatic scaling. You need like queuing to control the like communication between components. And all that stuff comes like for free with this serverless like remote procedure calling functions as a service architecture for Modal. So I didn't really demonstrate that. I probably should have shown you that with the Modal run thing, going up to 50 or 100 GPUs. But I want to make sure to leave time for questions. So that's the sort of thing you need, not just when you're doing your like hyperparameter sweeps in your training, but also when you're like, yeah, it's Christmas and everybody wants to generate a Christmas carol for their family, and you're Suno. Like we have a case study with them about that. So suddenly you need 1,000 GPUs, and then a couple hours later, everybody's asleep again, and you don't need any GPUs. That's automatic scaling. So there's a lot of pieces that came together to make this like actually good. A lot of it was like building lots of chunks of the stack, rebuilding it, like so Kubernetes and Docker type things. So there's lots of material about this, and I find the way that like Quinn and the organizations that he runs and works with share so much of their work really inspiring. So I wanted to include this. We actually talk quite a bit about the optimizations that we do to make your stuff run faster. So if you're interested, check out some of this material on the Modal blog, on Swix's podcast. Actually, I forgot this is his course too, and that's his podcast where he talked to our co-founder Eric about how we made Modal. Yeah, so the last thing I would say, this speaking of trending on Hacker News, for some reason, this like months-old blog post trended on Hacker News this past weekend. The like key reason to care about this, if you are running your own language models, running your own voice models, running anything on GPUs, like why does this matter so much in particular for GPUs? It's not just that it's, hard to get a hold of them or whatever. It's that like when you're managing your GPUs, actually because of the kind of supply constraints and the structure of the current cloud service providers, you end up needing to say ahead of time, yes, please give me 140 H100s or 100 in US East and 40 in EU West, right? And then you end up with like way too many GPUs for what your application needs most of the time. Like when your users all log on, maybe you need 80, but at night you only need like 10. But you're forced to over provision. And then like when you have those like big boosts and like a bunch of people show up to your website all at once, like that might not even be enough. And so you'll still end up with queuing, and you'll still end up with like degraded user experiences and longer latencies. That's if you just like provision everything ahead of time the way you would frequently do when starting off with a traditional cloud application. A lot of people will pretty immediately go to using something like Pulumi or Terraform, Tofu, whatever, to manage their stuff. But the problem you then run into is that if your allocations are slow, your utilization is still not great. You still have GPUs you've provisioned but are not using, and your quality of service will have problems. Like you'll lag behind these big spikes. It takes a while to get a hold of a new GPU from Amazon, check to make sure that it's working. Like you probably need to control the operating system and the drivers and all this stuff. And that takes time to install. And a lot of what the work that we did was to make that whole process fast and then jump past all that provisioning up to the point right where your code is about to run. And then you say, this is the code I want to run, and we start running it for you. And that allows you to really tightly match your allocation and your utilization. This is fake data here, but I checked with a couple of our customers, and it's like utilizations of 95% of their allocation are like extremely common. And that's compared to, again, this is also fictionalized, but there's industry reports and other things that indicate these states are very common and lead to utilizations of 60% or like as little as 10 or 20%. And that ends up in like very high costs. So the details about this and some more stuff about GPUs is there in that linked blog article on the Modal blog about GPU utilization. So yeah, controlling those costs, getting a hold of them, being able to effectively make use of infrastructure are like really critical for being able to serve these contemporary model capabilities on your own and deliver a good product. Like if you're not just relying on somebody else to run one of these APIs for you. We have the perfect case study that just landed on the blog like not too long ago. Lemon Slice does like real-time generative video stuff where you can like chat with the Mona Lisa or whatever, or upload a version of yourself that believes that they're a carrot and talk to them. So yeah, this is like Lemon Slice Live. This blog here, this case study explains like what they did and how they built it on the combination of Modal and Pipecat and Daily. So I'll make sure to share that one in the chat because I think that's probably of most like direct interest to folks here. Cool. All right. That's all the like planned content I had. So happy to take questions.
I have a bunch of questions.
Oh yeah.
I'm going to ask my questions first and be very rude. But as a bridge to the questions, I will toss out just a few things we see often from our customers that are driving interest in running on Modal. One is the lemon slice type use case where you've built a whole new infrastructure requiring set of models and you have a new kind of use case and you really need GPUs to scale for your customers. So in Lemon Slice's case, they have their own models that they've built from scratch and trained, and they're very unique. And it's not like you can just run them anywhere but in a GPU cloud. And Modal solves a bunch of infrastructure, automation, orchestration, scaling, reliability, management stuff for somebody like Lemon Slice. A second driver is data privacy. So there are whole classes of people starting to roll out voice AI applications using in various ways their own internal company data. So you're a big financial services company, you have very strict rules about what data you can send outside your virtual private cloud and what you can't. So you may not be able to use something like OpenAI or Google APIs, or you may be able to use those for some of your workloads, but not for others. So if you have a data processing agreement with Modal, it solves a lot of those kinds of problems. It can help you roll things out faster because you don't have to get approvals for every piece of it in the same way internally. It can help you roll things out that you wouldn't be able to roll out at all. We have customers doing internal applications that aren't actually even ever intended to be public facing, at least not now. And it's a lot easier to stand up something internal in some companies if it really is internal and it doesn't go out to, in some cases, a potential competitor of your very large company. And the third one is latency. So as we've talked about just a little bit, but we can dig into more with Charles, I think, and Chad, if you co-locate models all in one place, very close to your bot process, that can give you big latency gains. And it also gives you in a couple of ways. One is you eliminate some network round trip stuff. You can also tune the models. So if you're using public APIs, there's some balance that the public API providers decided was the right thing for their APIs between latency and throughput. And everybody's making economic calculations and trying to serve a very broad user base. If you really want low latency, you can just, to oversimplify, you can turn the latency knob all the way up and turn the throughput knob all the way down. And somebody like Charles can really help you with those calculations and go from like prototype to cost estimation to running at scale all on Modal. So that's my sort of quick, like, what do we see today that's pulling workloads over to Modal? There is a Modal Pipecat official starter kit project in the works.
Yeah, not launched yet, I think.
Okay.
But there's definitely modal Pipecat code floating around.
So I
Uh,
just like while we were in the call, I merged a PR in the Pipecat repo that also includes a really good modal deployment example from the Pipecat side.
oh, great. Sick. Yes. Exciting. We've been going back and forth on that for a bit, so it's great to hear.
Yeah.
There was already one, and we just made it even better. Production ready, even, you might say. Yeah.
I think we wrote the modal pipecat like demo that was in the docs for a while,
Mhm.
more than a year ago, like a long time ago. So it was very much time to bring that up to modern best practices, and I'm
Yeah.
excited about that getting released because it's super fun to deploy these voice agents and have them all run the models that like you curated right on a little GPU cluster, or in some cases the models are now small enough and capable enough you can run on one A100.
Yeah.
And that feels like the future. That feels like what we're all going to be able to do really trivially on infrastructure 3 or 4 years from now, and Modal makes it possible today.
Yeah. Yeah, definitely. Yeah, so I'd agree with Quinn's breakdown. Custom models are like the number one reason to run this thing yourself. There are other modals, fairly generic serverless cloud infrastructure, and there are providers who are like, "Oh, we'll run your fine tunes for you." It's not OpenAI, but there are people who run fine tunes for you. And the win with modal is the ability to run lots of different things, as Quinn suggested. Like you can co-locate the model with your bot process and save on latency, and so gaining extra control over that. The other reason we've seen people choose it to, I think, a question that I saw in the Zoom chat, the cost, right? Yeah. Like a lot of model providers have to run at very long maximum context lengths. And then the cost of context is quadratic, but everybody prices in dollars per token, which leads to this interesting thing where they need to guess how long people are going to send context to them when they set their pricing. And so if you have shorter context most of the time, which some kind of like interactive systems will have, you're probably already squishing your context down in order to hit latency targets. It actually is the case that you can run more cheaply at that shorter context length, provided you have sufficient load, than a provider. Even though that provider is like, specializing in this, aggregating a bunch of demand, has a bunch of advantages over somebody trying to run it themselves. The fact that you have shorter context lengths actually gives you this unbeatable speed up that can reduce cost. So that's maybe the only one I would add that we've seen a little bit of on top of what Quinn was talking about.
That's such a great call out because cost is something a lot of people are thinking about now as voice AI is starting to scale, and people are either scaling and trying to deal with cost growth or planning for scaling. And
Yeah.
what I often tell people is you really can't do better when you're prototyping or in the early days for most applications than Google can serve you tokens. Like they're just very good and also pricing very aggressively at the moment.
Yep.
So thinking about like cost optimizing by hosting your own models, if that's only driven by cost early on is probably the wrong order of thinking about things.
Yeah.
But if once you have a certain amount of traffic and you can plan for that traffic and you also know what the constituencies of that traffic is in terms of exactly what those inference calls are, as Charles said, you can do better than Google. Like the shape of the cost planning on modal, and Charles can jump in and make this more subtle or correct me, but I think of it as a planning for a base load. And you can get sophisticated about that, but basically you need to have a base amount of usage. And then you can cost optimize extremely well within that kind of band of usage. Whereas if you have highly variable traffic, you can still get there on modal, but it's probably a little easier, especially early on, to do that with the hosted APIs.
Yeah, I would say the one additional subtlety I would put in there is that if you need to be able to scale all the way down to zero, like no replicas alive, that's pretty hard on our system because it takes a minute to spin up. It takes literally a minute to spin up like an 8 billion parameter model on our system. There's some tricks we could use to speed it up. The main one being like snapshotting the GPU memory right when the model's about to start running, and then putting that in a disk somewhere or a database and restoring it. And there's just enough little tiny paper cuts that we haven't launched it as like an official feature, but it's coming quick soon, and that would allow us to do a little bit better on like scaling down to zero. Like you'd have a few seconds of extra latency the first time somebody comes in. But so long as you have at least sufficient base load to fill out one replica of your service, Then Modal's auto scaling allows you to go up to 10 times or 100 times as many replicas and back down. What we've seen is that people who are just starting out with language models or voice models in their applications don't have enough tokens per second to fill a single H100 because that thing can rip. Like we're talking millions of tokens in an hour, like already above the like lowest tiers of the APIs and even above some of the paid tiers. You just need to get to that like minimum level before it makes sense to run it yourself.
So if a rule of thumb, like very round number, takes 60 seconds to spin up from 0 to 1, what is 1 to 2?
So there, that the benefit there, and man, you can really nerd out about queuing theory on this stuff. There, all you need to be able to do is you've hit 40 requests per second, and that's like the maximum where you can still hit your latency SLA. And now 41 requests are coming in per second. You have one marginal request per second that you need to handle before that thing becomes a blowing up infinite queue. So the idea is that at that point, you like start spinning up something else, and you have 40 seconds before you've doubled your number of like in-flight requests. I think that math is right. I'd have to sit down and whiteboard that one out. But the basic point is that what's happening is requests are still landing on that like that existing replica, but maybe latencies are starting to increase.
Yeah.
And so that's what makes the 1 to n a lot easier because instead of a request coming in and experiencing the entire start latency always, it actually only experiences the latency for a slot to open up for it, which then depends on your request patterns. And yeah, but I think at 40 requests per second, I think there's an argument that at least for a brief period, it should only be 1/40th of a second. And so that suggests that the added latency now is down in the like milliseconds range. But you have a growing queue and that, so that assumption is going to break. So you maybe have 30 seconds to a minute at that load to spin up an additional replica.
So at the infrastructure level, going from 1 to 2 units is still 60 seconds. But the important thing is that at the application level, you actually already have the queues running. And so
Yes.
the impact on the end users is not that at all if you've thought about the system design.
Just to be clear, we're the ones running those queues. If you want to get even tighter control over stuff, which some of our running hundreds of thousands of dollars worth of compute on Modal a month, those people then start to use our existing queuing, like our lower level queuing primitives to like control stuff. But that's only when you're like really pushing the limits.
I actually think that's a great call out too, which is that one of the reasons Modal is so valuable is that none of these primitives exist on any of the hyperscalers. So you can buy GPUs from AWS or Azure or Google Cloud, but you will build everything yourself. And you may not need to build everything that Modal has. The nature of infrastructure is that like maybe you can do a subset of it, maybe. But it turns out that you always have to do more than you think. And I'm actually shocked by how slow the hyperscalers have been to get there with next generation GPU oriented tools. We lived through this through the WebRTC build out we did starting in like 2015, which was that when we started doing WebRTC, none of the building blocks on the hyperscalers were useful at all. In fact, even the networking layer stuff on the hyperscalers didn't really work very well. We had 2 years of like very close relationships with the AWS low-level networking team until UDP networking on AWS was as good as TCP networking. So I feel like I'm living through this again where sure you can use Bedrock and SageMaker, and you might even eventually be able to figure out what the difference is between Bedrock and SageMaker and which one you should use. But you will have to build a ton of stuff. And I work with the AWS team, and I think their infrastructure is great, but it's just a very different tooling problem. And there's just so much that Modal has built that you will need. For cold starts, it is about either over provisioning or making the cold starts faster. You guys have done a ton of magic to get it down to 1 minute. What do you say to people about the sort of over provisioning? You've got the queue thing, which gives you some flexibility, but do you say like when you're halfway into your number of requests per second you're aiming for, or your number of concurrent users you're aiming for, do you then just start to spin up another machine?
Yeah, we've added a little bit more flexibility there. You can have a sort of like minimum number of requests per replica that you tolerate and a maximum. And then you like kind of tune that for your deployment. And this is once you get to the larger scale. And that allows you to start spinning up before you get to the requests per second level that would degrade your latencies. And then you want to tune that number based off of the speed at which like spikes and changes in your traffic. We'll probably add, yeah, some additional autoscaler primitives. Zooming out a little bit, like to your point about the hyperscalers providing really high quality infrastructure that's a different beast, that layer is this sort of like metal layer that we're building on top of, right? Like we aren't building our own data centers. We aren't like reinventing the UDP networking wheel that Quinn worked with AWS to build. We're like building on top of that, trying to provide like a software layer that's actually more usable. That is what the majority of teams need. And AWS's largest customer, one of them, is the US government, who is happy to just throw money at building its own stuff for those kinds of things, or extremely large organizations maybe do something similar. I think it's like the snowflake pattern where it's pick something like a particular domain in which people need a specific thing. They need analytic queries answered, and Snowflake built like the right product for it, built the software layer on top of the raw affordances of S3 and EC2. Modal certainly could run our own analytic database on S3 and EC2. We like run lots of databases on Amazon, but it just makes much more sense for us as an organization to pay Snowflake to run that for us and handle a bunch of that stuff for us. And so our like the vision is, yeah, doing that same thing. And so providing like that higher level of abstraction. So far, we've only gone like one level of abstraction above. Like we run functions for people, we have remote storage, we have remote dictionaries. That's like just barely above what the hyperscalers already provide. But the vision is to keep going above it, which brings me to the like specific point I was going for, which is our autoscaler control is like relatively low level, relatively primitive. But as we grow as an organization and continue to ascend the ladder of abstraction, the hope is that you turn on like an autoscaler that watches your traffic and slowly figures out the rate at which requests tend to change. What's the rate of innovation or the highest frequency in your request patterns, and then sets those autoscaling things appropriately based on your latency targets. We're not there yet, but that's the vision of this sort of more usable cloud stack.
This is funny because as we've been working on Pipecat Cloud, which is our hosted platform for this stuff, I've been having a ton of conversations about, I call it the adolescent scaling problem, because it's what you said, Charles, where once you get to a certain level of scale, then you essentially have enough data for your autoscaler to, even if you haven't like auto scaled, you at least have enough consistent traffic for your autoscaler to understand what it's doing. And the problem that we're having, or the challenging thing, and I think that this is actually unique to some of these voice AI use cases, especially with something like Pipecat Cloud, is where like even a few seconds, like in a lot of other sort of AWS Lambda kind of circumstances and stuff, it's like a few seconds of cold start time might not be a huge deal. But like when you're talking, you have a user that has shown up, like literally dialed into your app or something like that. It's like we have to, what we're trying to do, at least with Pipecat Cloud, is effectively eliminate cold starts for that. And that is just a fundamentally different, challenging thing to say. I can't even deal with a few seconds of cold start time. And it's
Right.
paradoxically easier to solve that problem when you have a lot of traffic and you can just run excess capacity versus if you're trying to nickel and dime and say, I'm only getting users every few minutes. I don't want to pay out the nose for all these instances that I'm not using. So it's a weird, tricky thing for sure.
Yeah. Yeah, definitely. Our number one plan for solving that is definitely GPU snapshotting. The like fundamental limit there ends up just being RDMA, right? If you do GPU direct RDMA, that's more sophisticated than anything we even have prototyped for solving this problem. But like at that point, you are at like terabytes per second, maybe hundreds of gigabytes a second for GPU direct. And that's like your 8 billion parameter model in 100 milliseconds or a 70 billion parameter model in under a second.
Yeah, which is a very non-trivial problem, to put it mildly.
Yeah.
I feel like I should jump in here. The Discord is absolutely exploding with lots of really good questions.
I've got a couple of them, and like a good segue from the higher level tooling that you have to have that I don't actually know the answer to on Modal. Long running WebSocket connections and WebSocket like session affinity kind of routing, stuff like that. What do you guys do for WebSockets?
Yeah, so the WebSockets associated with modal function calls, and yeah. So like WebSockets are actually probably like the primary way or like the easiest way to get a sticky session in modal right now. That's why we use WebSockets for the protocol negotiation in the WebRTC example that I demoed. So yeah, there is a fundamental limit of 24 hours on modal. I don't know what scale of long running you're thinking of. Okay, good. Yeah, outgoing WebSocket connections. I haven't tried to do that, but when testing that RTC demo, we had two containers like connect to each other. So they certainly can do it. And yeah, I'll be honest, maybe there's a question in this that I'm missing because I don't know enough about networking, but I haven't run into any troubles with either long running WebSockets or doing outgoing WebSocket connections. But yeah, Stu.
Hi. Yeah, sorry, it's my question. I'm Stu from Layer Code. We have the joy of dealing with lots of WebSockets. At the moment, we are building on Cloudflare, which is great for the kind of zero cold boot and handling WebSockets. One of the things it's not great with is the fact that it's a V8. It doesn't handle headers and things like that as you would expect a normal WebSocket. But apart from that, we get great kind of performance from the WebSockets. I was just wondering, we've started porting a bunch of models, some of the text-to-speech models to Modal just this week. Started Orpheus, and I already played around with the Dia, the Nari Labs one, and I got that working offline on Modal last week. But we're looking at obviously streaming these things real time, and I'm just wondering how these things are going to scale, what they're going to look like when we've got thousands of users, how the back pressure works and stuff like that. We're using RxJS and stuff like that in our pipeline to handle streaming things in the kind of JavaScript way. How will that translate to interacting with Modal?
Yeah, that's a great question. I think, yeah, the basic answer is interactions with Modal map onto function calls, and we keep track of the number of function calls outstanding, and that's your queue. So in this case, the creation of a WebSocket, that's a function call. And so the number of outstanding WebSockets, every function call creates a WebSocket connection, and then a container will stick around as long as it has any WebSocket connection. And the function call lasts the lifetime of that WebSocket connection. And so then what you want to do is you want to make sure that like however many users you can like simultaneously land on a single container, you set that as like a concurrency limit on Modal, like running concurrent inputs. Those turn in, if you're presuming that would probably be, you would have some like async engine where the WebSocket message comes in, you pass that to the model service to handle. That's almost certainly going to be like async Python. And so your function calls really become like async tasks, right? So it's how many of these, at least start off of async tasks as they come in on the WebSocket, can you run simultaneously? Then what you would look at, let's say you can handle 10 or 20 simultaneous conversations with a single model replica because you can handle 5 to 10 at a time and users spend half the time silent. Then each modal replica can handle 10 to 20 simultaneous conversations. And every time like 5 to 10 more users show up, you would start like scaling up. When 5 to 10 users go away, you start scaling down when their WebSocket connections close. I think that basically covers what the scaling would look like.
We have a slightly more naive version in the Pipecat modal example where effectively we run function that is a fast API coordinator essentially that receives requests for new sessions with bots. And when it gets a request from a user, it spins up another function that essentially takes the information about the user that wants to talk to a bot. It spins up another function and hands that info to the running instance and says, here, in this case, we're using daily as the WebRTC transport. And so it says, here, spin up an instance of this function, go join this room and talk to the person that's there waiting for you. And so we have essentially one kind of manager function that runs, and then however many conversations we're having, we can do as many in parallel as Modal will let us scale up and pay for. And the nice thing with that too is that it also, you get this natural separation where like each function, like each instance that is running, you get separate logs for just that conversation with that user and stuff like that. So it maps onto that structure really nicely in a way that feels very correct.
Got it. Yeah. I think it depends on whether you need to multiplex users to save costs, which sounds a lot like AT&T. I thought we were in the web, but I guess that's over now.
Thank you. Cheers. Appreciate it.
Yeah, happy to talk more. Please, yeah, don't be shy to DM me or something.
Do you charge for storage?
We don't charge for storage right now. I think we'll eventually need to charge. Even Hugging Face now charges for storage at a certain scale. They were giving that away for free for a long time. So like that will happen to us eventually. The plan is to charge something like S3 rates, maybe like some small margin over S3 rates for storage, but for now it's free, and you will get a lot of like warnings ahead of time when we must change that. And a generous free tier, right? We have $30 a month of free compute already, so I would expect us to have a very generous storage free tier as well. That's like very important for us. It's hard to get a sense for infrastructure without trying it, right? Like you can read a bunch of docs or whatever, but until you actually try it, you don't really get it. And so the free tier is like a strategic imperative for us to convince people that what we've made is good. We want you to try it and see that it is good.
Can you run JavaScript code on Modal?
You sure can. I'll give you the like base version of the spiel, and then I'll give you the bonus one. So Modal runs containers. We have a Python runtime. Like you kind of land in a container by running a Python function. But it turns out Python is not, maybe primarily not a programming language, which is like hard for me to accept as somebody who learned it as my first language. It's actually a scripting language for Unix systems that's very good and better than Bash. And so actually what you can end up doing is like coordinating a bunch of processes from Python. And that might involve spinning up a node backend. And if you set the right decorators, you can just listen on a port. We'll wait for you to start listening on a port and then turn that into a web server. So that's what I use for when we're working on the blog or whatever. We like spin up versions of it on Modal as preview deployments. But with a node backend, Svelte front end, there's a whole bundle Webpacky thing in the middle. I'm not a web person like at my heart. And then I would say at this point, the underlying infrastructure that we've built is just to execute containers. And so like at some point in the future, we will have SDKs in other languages. You probably will end up defining a lot of your functions in Modal via Python for a while, but we'll have SDKs soon. Our founding engineer, Eric Zhang, put it together in a weekend, which was pretty shocking. And now we have JavaScript and Go SDKs. So that allows you to like manipulate code running on Modal from JavaScript and Go to like do remote procedure calling into Python from JavaScript and Go. Raymond is bringing up sandboxes. Modal functions are this like functions as a service, serverless thing. You tell us what Python function you want to run. Modal sandboxes provide a more of like a processy feel. It's like you spin a thing up and then you send messages to it on like standard in and read standard out. And that's it's a very processy feel. I actually, to a certain extent, prefer using Python to like manipulate processes from inside and then like standing up an HTTP server to the rest of the logic, but not everybody likes that. And so sandboxes have this more like processy feel. And so you can like pipe information in and out. And yeah, we have demos of running PHP on Modal and Ruby and things to show that you can do whatever it is that you want. So yeah, good call out, Raymond. So yeah, so there's a vision of building this as like a language agnostic infrastructure that's backed by this like auto scaling logic hardware, but a focus on Python for now.
Is there such a thing as Modal on-prem?
There is not such a thing as Modal on-prem. And I want to say that I'm going to maybe be slightly off script and say that there will never be such a thing as Modal on-prem. I think the party line is at some point in the future, we may offer Modal on-prem, blah, blah, blah. So the reason why Modal on-prem is like a category error is that fundamentally Modal is a supercomputer or a computing cluster built on top of the clouds, which you can deploy apps onto or rent time on. And so the only way in which it makes sense to run Modal on-prem is if you are at such a large scale that doing something like that inside of your organization makes sense. Where you have like multiple stakeholders, different organizations who all need vaguely similar infrastructure. And so they have a variety of demands that you can aggregate together, like where each one is sparse or they're decorrelated. And so you get this nice predictable load. Like then it would make sense. But the scale that we're talking about here is, Meta runs extreme functions as a service internally. And so they're at the scale where they would build something like this and could run Modal on-prem if they call me. But it's like very large scale. And that's like fundamental to the economics and the user experience is the existence of these like buffers, large scale.
What about something VPC or at least like network peering or VPN almost?
Something VPC something is another important part of this response. I personally have not been sold that virtual private clouds are anything other than like a compliance checkbox or like VP of engineering thing. I've been reading a lot of networking books trying to figure out. It feels like it keeps the peas and carrots separate from each other, but I'm not sure what else. But that said, at this point, I should comment that I'm the developer advocate at Modal. I don't run the security policy and I don't build the like networking stuff. So those people would give you a much more diplomatic and thoughtful and correct answer than what I said. But yes, VPC peering is a much simpler way to achieve better control of data and the construction modal applications in your organization, very technically feasible, unlike Modal on-prem, and so something we'd be interested in building with the right enterprise design partner.
Yeah, what I would say based on what we do with customers is if you have a data processing agreement that solves a lot of fundamental problems about kind of compliance, and then you probably do, to go with that, want some kind of dedicated network connection. It's no longer like an actual leased line in the world anymore. Functionally, what you're aiming for is something that feels like a dedicated network connection between a big company's data centers or VPCs and where Modal is hosting their GPUs. And you guys do have multiple regions. You can do data residency in specific regions. You can choose which cloud you're building on top of Modal.
Yeah, all those things are like they're available, but they either, I think regions are like a price multiplier. If you want to do region pinning, that's like pretty tightly tied to our own economics. If we want to have H100s in every region, now we need to run buffers, unallocated GPUs in every region. And so to control those costs, we have a price multiplier. Data residency, I think right now that means you have to drop down a little bit more to managing the stuff on S3. We have a cloud bucket mount abstraction that makes it feel like a file system, but you can no longer use like modal volumes, which are an even thicker file system abstraction over cloud network storage. Sorry, you asked about data residency, you asked about multiple regions and clouds. Yeah, you can also pin clouds. I think that might also come with either being part of a paid plan or a price multiplier, again, in order to map onto our own sort of like costs and the like implications of running infrastructure, being able to guarantee rapid sub-second access to infrastructure in all of the clouds in all of the regions. I think at larger scales, that ends up becoming like hundreds of GPUs, thousands of GPUs and more, that becomes an enterprise conversation where it's like we might need to run out ahead of you by a day or longer to be like, okay, we're gonna need 6,000 A10s in Japan. Okay, let's make sure we got that by the time that this big embedding job is going to run. Or you're going to launch your voice AI agent in Qatar, and so you anticipate this amount of traffic, so let's get that ready.
Cool. That all makes sense. Hopefully gives people some insight into if you're working with very large companies as a contractor or employee or on a product team, or if you are thinking about doing that in the future. These are all kind of very useful things to be able to talk to somebody like Charles about. We are pretty much at time, but Chad offered to show the modal Pipecat example. If anybody wants to stick around, if you're still up for that, Chad, that could be fun as a way to close this out.
Yeah, I'll try to do it very quickly. And also, Charles can either give us a thumbs up or recoil in horror at how we've chosen to do this. So, this was done by a colleague of ours named Maddie, who is phenomenal at this stuff. Let me find. Okay, so I'm trying to figure out the right way to show all of this. So, in the Pipecat repo, we made some improvements to this and updated. I just merged this PR 20 minutes ago or something. But if you go to Pipecat examples, deployment modal example, this is where we have a pretty standard Pipecat voice bot that we deployed and that runs on modal. So I mentioned we have this model where we have this kind of bot runner function. And this is where when you make like a fast API request, like this actually comes into our Python app and then gets sent out to a separate function that is this. The fast API app is the server one that comes in. And this is where, like, for example, when the Pipecat RTVI client goes to connect, it posts to this function, which is a fast API app. What this does is start a separate function, this bot runner function, and a call to this function is one ongoing session with a user. So you can see here, for example, this one executes 193 milliseconds to schedule and then cold start the container, another 1.2 0.71 seconds. And then when execution actually started, it ran for 14 seconds because this is how long I ended up talking to this particular bot. If you go look at some of these other function runs, you'll see they're a little bit longer. Here is a session, this was probably Maddie testing it earlier, where like she went back and forth with the bot for quite a while. And the cool thing with this is that you can see in the code. And so here's a picture of what it's doing. And actually, I should call out this over here. Speaking of running models locally or essentially adjacent inside Modal, that's one of the things we're doing here as well. We have a separate Modal app, which is, so we just went and grabbed one of the example apps of here's how you can essentially run your own instance of, I think this is Llama 3.1, using an interface that is already essentially compatible for Pipecat bots. And this is running on an H100. You can, like in the example code, and I can show this in a second, you essentially choose which LLM you want to use when you are starting up the bot. And so out of the box, this example supports OpenAI as well as Gemini, but also it supports this Modal, this Llama running on Modal. And so you can see some of the calls that get made to this particular app, but it's all basically in this example here. And if I go into the server folder and into app, you can see here up at the top of this is what Charles was talking about, where here is where we essentially define two different images for this particular function. One of them is the web image, and then one of them is the bot image. And if you get down into the guts, I won't necessarily walk through all the guts here, but if you get down into the guts here, you'll see we use a lot of these modal decorators. And effectively, when a web request comes in, it gets sent to this Fast API app, which eventually in the code here, you can find where it actually spins up a request to start that other function, that bot runner function, and it essentially passes it. Here's what you need to know to go connect to the user that is waiting to talk to this new instance of this bot. So it's pretty straightforward, but probably not worth me walking through all the guts of the code. But I will say, again, it's available in the Pipecat repo. Examples, deployment, modal is where this thing lives. And it works pretty well.
I think the patterns for all of this stuff are going to evolve a lot over the next little while because these use cases are relatively new and we're all trying to figure out the best way to build them. I liked what Charles said earlier in the call about, at least I thought I heard a slightly different pattern than this that might work really well for slightly different use cases or at more scale. So if you're interested in this stuff, we should all keep talking about it.
Yeah, definitely.
I will just say one more thing about WebRTC, which I wrote down as notes. So you have a couple of different ways to use WebRTC, and I think it's important to highlight that because people are more and more interested in the capabilities of WebRTC for these very low latency requirements. You can do what I call serverless WebRTC to help people understand the differences here. Your Python code or your bot code can negotiate a connection directly with the client application or web page. In that model, you're actually running the whole WebRTC process right inside your bot code. The most common way we do that, and Charles has been doing a bunch of that too, is to use a Python's WebRTC library called RTC. I always get that wrong. But it's now quite stable and good, and we use it a ton for various demos and examples and with some customers as well. For a long time, I told people not to use anything except, this is a little bit in the weeds, I told people not to use anything except some wrapping around the libWebRTC project that was the WebRTC standard for a very long time because you were just setting yourself up for a world of pain. If you see things that I've written that are on the web that are a couple years old that say that, I no longer think that. There have been huge amounts of progress in other WebRTC implementations, including AORTC, and we totally recommend it now. Almost all the standard Pipecat demos in like examples foundational now use this serverless WebRTC pattern. The Pipecat transport is called small WebRTC transport. So you can get up and running with WebRTC with no infrastructure required, no accounts required for any other service, no extra setup at all, just pip install, which is really cool. The other way you can use WebRTC is to route all the packets through some kind of server in the cloud, a WebRTC server that does a bunch more for you than just negotiate a peer-to-peer connection. We still recommend that for most large-scale use cases for a few reasons. The biggest single one is that you are going to get better performance routing through servers that are optimized for connecting people from the edge of the network and routing across the fastest possible backbone connections rather than people negotiating long connections over the public internet. We have lots and lots of data about that. So even if you have a server on the East Coast of the US and a user on the West Coast of the US, you're probably better off routing through really good cloud WebRTC infrastructure for the median user. Certainly, if you're routing from like Europe to the US or India to the US, you really don't want to negotiate those connections over the public internet. So, some of what we do at Daily is make the edge routed mesh WebRTC networking stuff work really well. We think that's worth using at scale or for critical use cases. And there's lots of observability and monitoring and debugging that comes with a platform like ours that you can use to understand how well your calls are working without having to build it yourself. But we now just say to people, if you're just getting started, try the serverless WebRTC stuff. You don't have to depend on anybody else's infrastructure to get pretty far.
Yep. To add a small bit of color on that, we've been playing around with this and have run into an absolutely, completely mysterious and unresolvable bug that only occurs at our co-working office's Wi-Fi using Firefox when trying to do a turn server. So that's the sort of thing. We haven't checked to see if that goes away with Pipecat, but if we were using Pipecat and Daily to do our software layer and infrastructure, we would at least have a much smaller surface area to debug. And that's just for a relatively small demo, not a like full scale application. So have already learned how useful standing on the shoulders of giants can be for this domain.